All right, 8.1. So we're going to start off with some review problems, just some concepts we're going to need in this chapter. So when you have two equal fractions, that is a proportion. To solve proportions, we are going to cross multiply and solve. So 8 times x equals 3 times 4. So 8x equals 12. We divide by 8. And we get x equals 12 over 8, which then reduces to 3 over 2. You divide top and bottom by 4. That's our final answer. Now, this one you got to be careful with. Whenever you have a plus or minus, a binomial, you must use parentheses. So the most common mistake, don't write this down, is to write this. 5x plus 3 equals 2 times 3. Problem is, the 5 is just being multiplied by the x, not the 3. We must use parentheses. So we get 5x, but also 15. Now I'm going to subtract 15 and get negative 9. Divide by 5, and there's my answer, negative 9 over 5. All right, now we're going to use the concepts we've learned to identify different angles here. All right, so I personally like to go for number 2 and 3 first, simply because 120, which is obtuse, and angle 3, which is acute, form a straight line. So they're a linear pair. And then 120 and number 2, which is also acute, is also a linear pair. But if you notice what we have here, 2 and 3 are vertical angles. So they are going to be equal to each other. So all I have to do is find one, and I found the other. It's going to be the same method, 180 minus 120. And instead of subtracting twice, I know it's the same thing. So 2 and 3 are both 60 degrees. Whoops. All right. So I want to point out something to you real quickly here. And it's a common mistake. Some people will look at, let's write in 60 here and 60 here. Some people will look at 5 and 6 and say, oh, well, those are 120 because they're opposite the 120. They're vertical. But think about it. Don't draw this. You don't have an x here with a 6, okay? Or with the 120. It doesn't work that way. Or with the 5. Okay? Same thing, it's the same drawing. You don't have vertical angles there. So those are not vertical. Don't fall into that trap. Now, something else to notice here is we have parallel lines, which means angle 1, this obtuse angle, is corresponding here with the 120. Remember, if I carry these out, all right, then 1 is an interior angle and 120 is an exterior angle. 1 and 120 are the same thing. Which now I know 4, if this is 120, then 4 is a linear pair to that, which makes number 4 60. Another reason number 4 is 60 is because 2 and 4 are alternate interior angles. Okay? Now, since these are parallel lines and we have a right angle right here, okay, that means this line right here, which is a transversal of the two parallel lines, that means this is 90 right here also. And if you notice, these are both marked equal. So that means this is 45 and this is 45. Now you might think, well, we don't need those. There's no numbers there. We need them to find 5 and 6. So there's two ways to do this. You can find 5 or 6 next, doesn't really matter. So number 5 is in this triangle right here. And so far we have 60 plus 45, which is 105. So if we subtract 180 minus 105, then we get 75. So angle 5 is 75 degrees. Now there's 2 ways to get 6, or 3 ways. We can add 60 and 75 and find this straight line right here. We can do the 60 and 75 right here, same math. Or this triangle right here, 90 plus 45, and subtract that from 180. It really makes no difference. We're going to get 45 degrees right here. Or if you just think about it, shortcut is if this is 90, the other two must equal 90, and if this is 45, then this must also be 45. So a lot of different ways to get there. That's just the way I went. All right, new stuff. So we've been talking this whole time for quite a while about congruent triangles. And now we're going to introduce the idea of similarity, similar polygons. We're going to use this symbol right here, this wavy line. So it says in the diagram below, ABC is similar to DEF. All right. So in other words, it's like a scale model. All right. If you ever built a scale model of a car or a plane or something, or seen an action figure that's a scale model, that means it's exactly the same. All the dimensions are the same. It's just smaller, a smaller version of the real thing or of a building. So sometimes you'll see a scale model that's 1/8 the real size, or 1/16 or 1/32, which just means if you multiplied everything on there by 32, you would have the full size, whatever it is. All right? So when we have, this is going to be our new statement here, triangle ABC is similar to triangle DEF. So a similarity transformation keeps the angles the same. So you'll notice the angles are marked. So this has 2, that has 2. C and F both have 2. A and D both have, C and F both have 3. And then A and D both have 1. So the angles are the same. And notice our little trick will still work that we've done before. We're just not going to be able to make all the same statements, but we can say A lines up with D, B lines up with E, and C lines up with F. All right. Now, there's a ratio. So this side right here is going to be multiplied by a number or a fraction, whole number or fraction, to get that side. That's K. That's our rate. Notice B is going to be multiplied by the same number, and C is going to be multiplied by the same number. So you can't multiply 2 sides by 3 and 1 side by 5. They must be all multiplied by the same number to keep the ratio. So you see here, DE is proportionate to AB. DE, AB. The same way EF is proportionate to BC. EF, BC. Just like we've done before, except we're talking about similarity. All right. So in the diagram, RST, XYZ. So I'm going to immediately write XYZ underneath. All right. So I notice RST is going this way. XYZ, they are lined up in the same order. So I'm good to go. So notice 25 is going to match with this, 30 is going to match with this, and 20 is going to match with this. Now, it says find the scale factor from RST to XYZ. Now, if you think about it, I had to erase that, sorry. So if you think about it, from RST to XYZ, are you getting bigger or smaller? All right, you're getting smaller, which is a reduction. So let's think about it. Do we want to write 25 over 15? Or do we want to write 15 over 25? This is where a little common sense comes in. We're getting smaller. So this number, the top number is bigger than the bottom number. All right, that means it's bigger than 1. Here we have an improper fraction, I'm sorry, a proper fraction, where the top is smaller than the bottom, which means this is less than 1. We're getting smaller on that one. So we want the smaller number on the top. So I want XYZ on the top and RST on the bottom. So if I look at XY, that's 15. RT is 25. ZY is 18. And TS is 30. And then the last one is 12 and 20. Now, all these are reducible. I can divide and get a smaller fraction, reduced fraction, simplified fraction. So 15 and 25 both share a 5. If I divide by 5, I get 3/5. 18 and 30 both share a 6. Guess what? Divide by 6, you get 3/5. 12 and 20 both have a 4. When you divide, you get 3/5. This is the scale factor. This is K. In other words, if I multiply this number by 3/5, multiply by 3, divide by 5, I will get 18. Right? The most common mistake here is to put the big number on top because you think, oh, I'm going from this to this, so I go in order. Well, in this case, you're getting smaller, so you need a smaller number on the top. List all pairs of congruent angles. Well, that's our little trick right here. So angle R is congruent to angle X. Angle S is congruent to angle Y. And angle T is congruent to angle Z. Write the ratios of the corresponding side lengths in a statement of proportionality. Well, we kind of did that already. So 15 and 25, right? So 15 was ZX, and 25 was TR. Sorry. Yeah. And then YX and SR. And then XZ and RT. And that's basically the letter version of what we have up here. All right. If two polygons are similar, then the ratio of any two corresponding lengths is equal to the scale factor. All right. So in the diagram here, DEF is similar to MNP, DEF. So first, I want to make sure that I have it lined up so the order is the same. So DEF is going this way, MNP is going that way, so they line up. So those two correspond, those two, and those two. Okay? So to solve this, it doesn't matter which way you go, okay? Big or small on the top, it doesn't matter. But I like to set up a word ratio. So I'm going to put the big one on top and small on the bottom. It doesn't matter. It'll work out the same way. All right. And I set up this before I even do anything. All right. And then I pick, words that work to describe what I'm going to use. So if I'm going to use, let's say 24 and 20, that's the bottom. Okay. Or maybe the base, the bottom, whatever. And then my unknown is on the slant. If you want to call it the hypotenuse, even though we don't know it's a 90-degree angle, whatever word works for you. And now you just fill it in. It's hard to make mistakes here. So the big base is 24, and the small base is 20. And the big slant is 30, and the small slant is X. And now I do what we reviewed at the beginning. 24X equals 20 times 30, which you don't need a calculator for. Okay, 24x equals 2 times 3 is 6, and then 2 zeros. Now you might need a calculator for this part. That's okay. So x is 25 when you divide. So this side right here is 25. Now, I just want to show you, if you want to skip this, you can, but I just want to show you that it would work out no matter what we did. So let's say I did small over big, and I use the left side and the slant. Watch how easy this is. Every time, it's hard to make a mistake. Okay, so the small left side is 15, and the big left side is 18. And the small slant is x, and the big slant is 30. I would get 18x equals 30 times 15. So that's 18x equals 450. And guess what I would get if I divided by 18? I would still get 25. So this system is almost foolproof. All right, example 3. In the diagram, TPR is similar to XPZ. Okay, so TPR, right? So this way, XPZ this way. So that means T and X line up, which we can see right here, right? Just to keep it or order. Find the length of the altitude PS. So we're looking for this piece right here. So if we look, we have information here. This is 12 and this is 16, right? So we have our small triangle and our big triangle. We have our base, and we have our altitude. So the small base is 12. The big base is 16. The small altitude is unknown. The big altitude is 20. 16 times x equals 12 times 20. Easy to do in our head, the first part at least. 2 times 12 is 24, and tack on the 0. And then we just need to do 240 divided by 16, which is 15. So this right here is 15. All right, the perimeters of similar polygons. If two polygons are similar, the ratio of their perimeters is equal to the ratios of their corresponding side lengths. So let's see what that means. KLMN, PQRS are similar. These two shapes are similar. Therefore, PQ plus QR plus RS plus SP, that's the perimeter of the big one, is equal to over KL plus LM plus MN plus KM, that perimeter. Okay, so the perimeter ratio of the perimeters is equal to whatever the ratio is of this side to this side, or this side to this side, and so forth. So, a town plans to build a new swimming pool. An Olympic pool is rectangular with a length of 50 and a width of 25. The new pool will be similar in shape, but will have a length of 40. So it's going to be a little bit smaller. It's going to have a length of 40. Find the perimeters of the Olympic pool and the new pool. Well, the perimeter of the big pool is easy. You just add up those numbers. So the perimeter of the Olympic is 50 plus 50 is 100, 25 and 25 is 50, so that is 150 meters. Okay? Now, we need to find out this measurement right here. Okay? So, I'm going to set up my little word wall here. So I'm going to have big over small and length and width. So the big length is 50, the small length is 40. The big width is 25, and we don't know this. So now we cross multiply, and we get 50x equals 25 times 40. Okay, nice little trick here again. 50x, 4 times 25 is 100. Tack on a 0. So now we divide. So 1,000 divided by 50. X equals 20. So the perimeter of the smaller pool is going to be 40 plus 40 is 80. 20 and 20 is 40. So 120 meters. Now that is one way to do it. Now I'm going to show you with the new rule we just learned. And we're going to set up this way. So we're going to have big and small. And we're going to have the length that we know and the perimeter, because it has the same proportion. So the big length is 50, and the small length is 40. The big perimeter we figured out was 150, and now we're trying to find out this perimeter. So we're going to cross multiply. 150 times 40 equals 50x. This is going to be 600 equals 50x. And when we divide, we get x equals 120, which is the same answer, just a quicker way of getting there. Since it did not ask us to find this, we did not spend time finding it. We could have gone directly to the answer. But I do want you to see there's two different ways to do it. Okay? Areas of similar polygons. Now, this is a little bit different. Okay? It says if two polygons are similar, these two are similar, then the ratio of their areas is equal to the square of the ratios of their corresponding side lengths. So whatever this proportion is, we need to square it for area. All right, so A, B, C, D, E, F. Okay? So they're lined up the same way, right? So what we're going to do is we're going to take that proportion, okay? ABC over DEF, that proportion is 10 over 5 because these two sides correspond, AB and DE, all right? Now, what is that? That is 2 over 1 or just simply 2. So that's the ratio of the sides, okay? But the ratio of the areas is 2 squared, which is 4. So if we know the area of this one is 36, and the ratio is 4, we need to divide by 4 and get 9 for this one. So there's a 2-to-1 ratio on the side lengths, but there's a 4-to-1 ratio on the area because 2 squared is 4. All right, decide whether ABCDE and KLQRP are similar. So A, B, C, D, E. All right. Well, notice first off, right there, A and K, which we have lined up here, right, are not congruent, sorry, corresponding. So if you notice, you got to follow the order. So we're trying to see if KLRPQ going this way is the same as going that way. So we need to see if 12 and 8, what that ratio is. So if we reduce that ratio, 12 divided by 4 is 3, and that's 2. Okay? So that's a proportion of 3 halves. Let's see, we have to check every one though. So 9 over 8, we're doing these two. Well, 3 divided by 3 is 3. Sorry, my bad. I just realized we made a mistake here, which happens. We're going this way, right? So 9 corresponds with the 6, BC, and LQ. So 9 and 6, divide by 3, we get 3. Divide by 3, we get 2. That works. Then CD is RQ. So 6 over 4. We just keep checking this. So they're both even. If we divide by 2, we get 3 and 2. All right? How about DE and PR? Again, DE and PR, RP. So we have 9 over 6, which we've already done. So we know that works. And last but not least, we have 12 and 8, which we've already done here. So yes, they all check out. So the answer is yes. All sides are proportional.